Hello friends, myself Subhash Nagarse from Sri Digambar Jain Gurukul High School, Solapur. I shall welcome to all of you in this online session of 10th Standard Mathematics Part 2. And the topic is Mensuration Part 4. Today we are going to discuss on sector of a circle, area of a sector, length of an arc, a relation between length of an arc and area of sector, and problems based on the above content. Friends, in the previous session of this mensuration part 3, we have been discussed with the following important subtopics of this chapter. That is frustum of a cone, surface area and volume of frustum of a cone, problems based on the above content. Today, in this session, we are going to discuss on sector of a circle. So, sector of a circle. Friends, in the adjoining figure, the central angle divides the circular region into parts. Each of the part is called sector of the circle. Sector of a circle is the part enclosed by two radii of the circle and the arc joining their endpoints. In the adjoining figure, OPAQ and OPBQ are two sectors of a circle. There are two types of sector of a circle. That is, first, minor sector. Sector of a circle enclosed by two radii and their corresponding minor arc is called as the minor sector. In the adjoining figure, OPAQ is a minor sector. Second, major sector. Sector of a circle that is enclosed by two radii and their corresponding major arc is called as the major sector. In the adjoining figure, OPBQ is the major sector. Arc of a area of a sector. Friends, an area of this sector is like a pizza slice of the circle. It consists of a region bounded by two radii and an arc lying between the radii. The area of sector is a fraction of the area of the circle. This area is proportional to the central angle. In other words, the bigger the central angle, the larger is the area of the sector. The adjoining diagrams give the formulas for the area of circle and the area of sector. So, area of the circle is pi r square and area of sector is equal to theta upon 360 into pi r square. Friends, now length of an arc. The arc length is the distance between the endpoints along the circle. Arc measure is a degree measurement equal to the central angle that forms the intercepted arc. Arc length is a fraction of the circumference of the circle. The adjoining diagram gives the information about the formulas to calculate the arc length of a circle. So, arc length is equal to theta upon 360 into 2 pi r. Now, what is the relation between an arc and the area of a sector? Friends, we know that area of a sector A is equal to theta upon 360 into pi r square, equation 1, and the length of an arc L is equal to theta upon 360 into 2 pi r. Therefore, theta upon 360 is equal to L upon 2 pi r. Therefore, area A is equal to L upon 2 pi r into pi r square. We have been substituting equation 2 in equation 1. Therefore, A is equal to L by 1 upon 2 into r. Therefore, you can write A is equal to LR by 2. That is, area of the sector is equal to length of arc into radius divided by 2. Or in general, you can write A upon pi r square is equal to L upon 2 pi r is equal to theta upon 360. So friends, let us discuss few problems that are based on these formulas and the content. Number 1, radius of the circle is 10 centimeter. Measure of an arc of the circle is 54 degree. Find the area of the sector associated with the arc. Given pi is equal to 3.14. Friends, given the radius r is equal to 10 centimeter and measure of the arc theta is 54 degree, we know that we are going to find out the area of a sector. So, area of a sector is equal to theta upon 360 into pi r square. Now we will substitute the values. Theta 54 upon 360 into 3.14 into 10 square, which is 3 upon 20 into 3.14 into 100, which will be equal to 3 into 3.14 into 5. Therefore, area of the sector is equal to 15 into 3.14, which will be 47.5 10 centimeter square. So the area of the sector is 47.1 centimeter square. Problem number 2. Measure of an arc of a circle is 80 degree and its radius is 18 centimeter. Find the length of the arc given that pi is equal to 3.14. Friends, radius r is equal to 18 centimeter and the measure of the arc theta is 80 degree, and we have to find out the length of the arc. Let us have the solution. Length of arc is equal to theta upon 360 into 2 pi r, which will be 80 upon 360 into 2 into 3.14 into 18. You have substituted the values of theta and r. Therefore, you will get 2 upon 9 into 2 into 3.14 into 18, which will be 2 into 2, 3.14 into 2. So that leads to length of an arc is equal to 8 into 3.14, which will be equal to 25.12 centimeter. Therefore, the length of the arc is 25.12 centimeter. Friends, let us consider third problem. Radius of the sector of a circle is 3.5 centimeter and the length of its arc is 2.2 centimeter. Find the area of the sector. Friends, it is given that radius r is 3.5 centimeter, length of the arc L is 2.2 centimeter. To find area of the sector, so the solution, the formula will be area of the sector is equal to L into r by 2, which is 2.2 into 3.55 divided by 2. So area of the sector is equal to 1.1 into 3.5, that will be 3.85 square centimeter. That is, the area of the sector is equal to 3.85 centimeter square. Problem number 4. Radius of the circle is 10 centimeter and area of the sector of the circle is 100 centimeter square. Find the area of its corresponding measure sector. Pi is equal to 3.14. Friends, it is given that radius r is equal to 10 centimeter, area of the minor sector is equal to 100 centimeter square. So you have to find out area of the major sector. So solution, here the area of the circle is pi r square, which is equal to 3.14 into 10 square. Radius is 10. Therefore 3.14 into 100, that will be 314 square centimeter. Now area of the sector is equal to area of the circle minus area of the minor arc. So 314 minus 100, that gives you 214 centimeter square. Therefore, the area of the corresponding major sector is 214 square centimeter. Now problem number 5. Area of the sector of a circle of radius 15 centimeter is 10 centimeter square. Find the length of the arc of the sector. Now we know the given things, that is radius r is equal to 15 centimeter, area of the sector is 30 centimeter square. You have to find out the length of the arc. So solution is area of the sector is equal to L into r by 2. Therefore length of the arc is equal to 2 into a upon r, which will be 2 into 30 upon 15. So that will be 60 upon 15, which will be 4 centimeter. Therefore the length of the arc is 4 centimeter. Problem 6. In the adjoining figure, radius of the circle is 7 centimeter and measurement of the arc MBN is 60 degree. Find area of the circle, area of OMBN and the area of OMCN. Friends, radius r is 7 centimeter and the measurement of the arc MBN is theta, which will be 60 degree. We have area of the circle, area of the sector OMBN and area of the sector OMCN we have to find out. So area of the circle is equal to pi r square, which will be 22 upon 7 into 7 square, which will be 22 upon 7 into 49, which is 22 upon 7, which will be 154 square centimeter. Here central angle theta is equal to MON, which is 60 degree given. We have area of the sector is equal to theta upon 360 into pi r square, which will be 60 upon 360 into 22 upon 7 into 7 into 7. After substituting the values, we will simplify this one. So 1 upon 6 into 22 into 7, which will be 25.67 centimeter square. Therefore, area of the sector OMBN is equal to 25.67 centimeter square. The third, area of the major sector is equal to area of the circle minus area of the minor sector. So here, therefore, area of the sector OMCN will be equal to area of the circle minus area of OMBN, which will be 154 minus 25.7, which will be 128.3 centimeter square. Now, therefore, area of the sector OMCN is 128.3 centimeter square. Problem number 7. In the adjoining figure, radius of the circle is 3.4 centimeter and the perimeter of the sector is PABC is 12.8 centimeter. Find the area of the sector PABC. It is given that radius of the circle R is equal to 3.4 centimeter and perimeter of the sector is 12.8 centimeter, and you have to find out area of the sector PABC. Friends, we have perimeter of the sector is equal to length of the arc ABC plus AP plus CP. So which will be 12.8 is equal to 1 plus 3.4 plus 3.4. So the length 12.8 is equal to length L plus 6.8. Therefore, L is equal to 12.8 minus 6.8, that will be 6 centimeter. Now, area of the sector PABC is equal to L into R divided by 2, which will be 6 into 3.14 divided by 2, which will be 3 into 3.4, that will be 10.2 square centimeter. Therefore, area of the sector PABC is equal to 10.2 centimeter square. Now, problem number 8. In the adjoining figure, O is the center of the sector circle and that of the sector also. Angle ROQ is equal to angle MON is equal to 60 degree. OR is 7 centimeter and OM is equal to 21 centimeter. Find the length of the RXQ, where pi is given 22/7. Friends, here angle ROQ is equal to angle MON is equal to 60 degree. Therefore, radius R is equal to OR, which will be 7 centimeter. So, radius R, that OM, is also 21 centimeter. OR and OM, which are given 7 centimeter and 21 centimeter respectively. Now, length of the arc RXQ and arc MON you have to find out. We start. Length of the arc RXQ is equal to theta upon 360 into 2 pi r, which will be 60 upon 360 into 2 into 22/7 into 7. So, which will be 1/6 into 22 into 2, which will be 7.33 centimeter. Therefore, length of arc RXQ is equal to 7.33 centimeter. Length of the arc MON is equal to theta upon 360 into 2 pi r, which will be 60 upon 360 into 2 into 22/7 into 21, which could be 1/6 into 2 into 22 into 3, which will be 22 centimeter. Therefore, length of arc MON is equal to 22 centimeter. The next problem number 9. In the adjoining figure, if area of the sector PABC is 154 centimeter square, radius of the circle is 14 centimeter, find angle APC and measure length of arc ABC. Friends, we have that area of the sector PABC is 154 centimeter square and radius R is 14 centimeter square, and we have to find out angle APC and the length of the arc ABC. We will start now with let angle APC is equal to theta. Therefore, area of the sector PABC is equal to theta upon 360 into pi r square. We will substitute the values. Therefore, 154 is equal to theta upon 360 into 22/7 into 14 square. R is 14. Therefore, theta can be written as 154 into 360 into 7 upon 22 into 14 square, which will be 154 into 360 into 7 upon 22 into 14 into 14. After simplification, you will write theta is equal to 7 into 360 upon 14 into 2, which will be 360 divided by 2 into 2, that is 90 degree. So, angle APC is 90. Next, let theta be 90. Therefore, length of the arc ABC is equal to theta upon 360 into 2 pi r. Therefore, 90 upon 360 into 2 into 22/7 into 14. We have been substituted here the values of theta and r. Therefore, 1/4 after simplification we are getting 1/4 into 2 into 22 into 2. Therefore, length of the arc ABC is equal to 22 centimeter. Therefore, length of the arc ABC could be 22 centimeter. Let problem number 10. The area of the minor sector of a circle is 3.85 centimeter square and the measure of its central angle is 36 degree. Find the radius of the circle. Friends, given that area of the minor sector is equal to 3.85 centimeter square and the central angle theta is equal to 36 degree, we have to find out radius of the circle R. Friends, area of the minor sector is equal to theta upon 360 into pi r square. Therefore, substitute the values. 3.85 is equal to 36 upon 360 into 22/7 into r square. Therefore, 3.85 is equal to 1 upon 10 into 22 upon 7 into r square. After simplification, you can write r square is equal to 3.85 into 10 into 7 upon 22. Therefore, 385 upon 100 into 10 upon 22 is equal to into 7. Therefore, you can write r square will be equal to this 385 upon 10 into 7 upon 22. Therefore, friends, r square is equal to 77 upon 2 into 7 upon 22. R square is equal to 7 into 7 upon 2 into 2. Therefore, r is equal to 7 by 2, taking square root on both sides. Sector is equal to 3.5 centimeter. So, the radius of the circle is 3.5 centimeter. Here, taking square root on both sides, we are getting r is 3.5 centimeter. Problem 11. In the given figure, quadrilateral PQRS is a rectangle. If PQ is equal to 14 cm, QR is equal to 21 cm. Find the areas of the parts X, Y and Z. Friends, here it is given that quadrilateral PQRS is a rectangle where PQ is equal to 14 cm, QR is equal to 21 cm. We have to find out the areas of the parts X, Y and Z. Friends, angle Q is equal to angle R is equal to theta, which will be 90. These are the angles of the rectangle. Now, area of part X is equal to theta upon 360 into pi r square. From the figure, we have 90 upon 360 into 22 upon 7 into PQ square. So, 1 upon 4 into 22 upon 7 into 14 square. So, 1 upon 4 into 22 upon 7 into 14, which will be 1 by 2 into 11 into 2 into 14. So, here it is 11 into 14, which will be 154. Therefore, area of the part A is 154 square centimeter. For the sector QPA, we have PQ is equal to QA, radius of the same circle. Therefore, QA is equal to 14. Now, QR is equal to QA plus AR. Therefore, you can write 21 is equal to 14 plus AR. Therefore, you are getting AR is equal to 7. So, friends, here from the adjoining figure, area of the part Y will be theta upon 360 into pi r square. So, 90 upon 360 into 22 upon 7 into AR square, which will be 1 upon 4 into 22 upon 7 into 7 square. So, 1 upon 4 into 22 upon 7 into 7 into 7. So, which will be 1 upon 4 into 22 into 7. Therefore, 154 upon 4. So, which will be 38.5 square centimeter. Therefore, area of the part Y is 38.5 square centimeter. The area of the rectangle PQRS is equal to length and breadth, which length into breadth, which will be PQ into QR, that is 14 into 21. Therefore, area of the rectangle PQRS will be equal to 294 centimeter square. Friends, now we will find out the area of the part Z, which will be equal to area of the rectangle PQRS minus area of the part X minus area of the part Y. So, which will be area of the part Z is equal to 294 minus 154 minus 38.5, which is 101.5 square centimeter. Therefore, area of the part Z will be 101.5 centimeter square. Friends, let us consider this one more problem. A triangle LMN is an isosceles triangle. LM was 14 centimeter. As shown in the figure, 3 sectors are drawn with vertices as center and radius as 7 centimeter. Find area of the triangle LMN, area of one of the sectors, total area of all the 3 sectors, area of the shaded region. Root 3 is equal to 1.732. In equilateral triangle LMN, LM is 14 centimeter, so radius of the sector R is equal to 7 centimeter. Triangle LMN is an equilateral triangle, therefore area of triangle LMN is equal to root 3 upon 4 into LM square, which will be root 3 upon 4 into 12 square. So 49 into 1.732, that will be 84.868. That is approximately 84.87 centimeter square. Area of triangle LMN is equal to 84.87 square centimeter. Now, central angle theta is equal to 60 degree. That is the angle of the equilateral triangle. So, area of sector is equal to theta upon 360 into pi r square. Substitute the values. 60 upon 360 into 22 upon 7 into 7 square. So, which will be 1 upon 6 into 22 into 7. Therefore, 11 into 7 upon 3, which will be equal to 77 upon 3. therefore which will be equal to 25.67 centimeter square. Therefore area of the sector is equal to 25.67 centimeter square. Friends, total area of all the three sectors will be equal to 3 into area of the one sector. So 3 into 25.67, which will be 77.01 centimeter square. So total area of the three sectors is equal to 77.01 centimeter square. The area of the shaded region is equal to area of triangle element minus total area of the three sectors. So 84.87 minus 77.01, which will be 7.86 centimeter square. Therefore area of the shaded region is equal to 7.86 centimeter square. Friends, what we have been discussed today is, in this session we have discussed on the following subtopics of this chapter, that is sector of a circle, area of sector, length of an arc, a relation between length of an arc and the area of the sector, and problems based on this content. Friends, you try these problems. The area of sector of a circle is 6 cm and radius is 157 square centimeter. Find the measure of the arc and length of the corresponding to the sector. Find the perimeter of a sector of a circle if its measure is 90 degree and radius is 7 centimeter. If measure of an arc of a circle is 160 and its length is 44 centimeter, find the circumference of the circle. So friends, you should not forget the famous words of Albert Einstein. What he said: a person who never made a mistake never tried anything new. Very nice wording for you. So if you like this video, please subscribe, share. With these words, I would like to say thank you.